All right, so that one was incorrect, but that's okay. All right. So here we have a rate solving question. We can't see the question here, but I'll draw out the table. So we have this equation, just a general chemical equation, and we're given 3 trials and initial concentrations for each of the 2 reactants and a measured rate. So for trial 1, 0.250, 0.200, okay, and so now we have 3 trials with 3 different sets of conditions and 3 rates. Our general rate law is going to be our rate constant times our concentration of A to some factor, which is the order in A, and our concentration of B to some factor, which is the order in B. And the question wants us to solve for N, M, and K. Okay, so the way to go about this is to write out what our equations are here. So from the first trial, we have at 0.0215, and I should put that the units on this are molars per second. But in solving it, just for clarity, I'm going to drop the units. So K times 0.250 to the N, 0.200 to the M. Our second equation is 0.145, 0.250 to the N, 0.520 to the M. And our third equation is 0.0301 is 50 to the N, 0.200 to the M. Okay, so to go about starting this, we basically need to find 2 equations that we can divide by one another to get rid of the most things so we can solve it. So if we look at 1, we have K times 0.250 to the N. If we look at 2, we have K times 0.250 to the N. And so if we divide these 2, those factors will cancel. So 2 divided by 1 is 0.145 over 0.0215 equals K. I'm just going to write them out completely so you can see. And so we can see that the K's will cancel, the 0.250's the N will cancel, and all we're left with is the M powers. If we run this on our calculator here, so this division here comes out to be 6.744186, and this division here comes out to be 2.6 to the power of M. Found N. There we go. 2.6 to the power of M. To solve for m now, we need to take the logarithm of both sides and use one of the log rules. So log 6.744186 is equal to, so if we take the log of this, we can bring the power down. So that becomes m log 2.6, or m equals log of 6.744186 over the log of 2.6. Doing that division using your calculator, this comes out to be 1.998, which is approximately 2. So for the orders, I would say we would always want to round to the nearest integer value. And so it looks like we're second order in B. Okay, so we're second order in B. Okay, so now for our next equation, or to solve for n, we would play the same game. So we would look for two of these equations where we can remove everything except the n's. And so if we look at our 1 and our 3, we have this factor in both of them. And so it looks like if we take 3 and divide by 1, then we will get our n on its own. And so just doing that now. So 3 divided by 1 is 0.0301 over 215, which is equal to, I guess I should write them out completely. So K 0.350 to the n, 0.200 to the m. Now we know what m is, but I'm just going to leave it because it's going to cancel. 250 and 200. Okay, so the k's will cancel, these guys will cancel. Running this through on our calculator, we get 1.4 is equal to, and that same division as well, 1.4 to the n, taking the logarithm of both sides. And solving for n. And we don't actually need our calculator here because log of 1.4 over log of 1.4 is just 1. So now now we have both n and m. It's first order in n. So our rate law is k concentration of A to the 1, concentration of B to the 2. Now to solve for our K, we can just use any of our rates. And to get proper units on the K, I'm going to, any of our equations, and to get proper units, I'm just going to put our units back in. So I'm just going to use the first equation. So 0.0215, and that was in molars per second, is K, and A is 0.250 molar, and B was 0.200 for the first trial, and that would be squared. Rearranging for our K, it's 0.0215 molar per second over 0.250 molar, 0.200 molar squared. And so one of these molars will cancel that. but then we're going to have a 1 over molar squared second. So doing this division, not forgetting the square there, we get 2.15, 1 over molar squared seconds. And so there's our K. And so now we've got our full rate expression. So the rate is 2.15, 1 over molar squared second, concentration of A, concentration of B squared. And that's our full rate expression. Okay, so checking the solution, we use our general expression here, and so we write our three equations, divide based on getting the same things. Go to the end, we get KAB squared, solving for K, 2.15, and it's 1 over molar squared seconds, so that all looks good. Okay.